Hi friends, welcome to our channel. Today, let's talk about a programming question, which is LeetCode Question 11, container with the most water. In these questions, we have different lines with different heights, and we want to determine the container that have most water. Mathematically, we are finding the areas of the rectangles that are maximums. Let's see what happens. Formally, we know that the area equals to the width here times the height here, right? And for these two bars with different length, with different height, only the bar with smaller height matters. Let's show you another example. So let's control it. If we have these two bars, these two green bars, and the width is here, the area is determined by this part, this blue part only, which corresponds to the smaller height. Okay, so let's go back to questions. Before solving any questions, let's consider the basis. What if there are only two lines, right? Which is here and here. Of course, only the smaller lines matter. So we can write down the code here as the base case. Let me use the smaller letter. If length height equals to 2, we can just return the minimum of the height, the first term and the second term. And then here we can use some test case to check the result. For example, we can have 8 and 6 and 3 and 7 here, and then we can press here to run some test case. Okay, sorry, I think we misspelled here. So let me just press it again. Okay, all good. Okay, let's consider general case, which is we have 3 or more bars. As we previously noted, the areas depends on two things: the height here and the width here, and we want to maximize both of them. And the height here is equal to the minimum of the left one and the right one. Okay, so we should just maximize the minimum of both height. Okay, so let's use a two-pointer method to tackle it. So let's remove it. So let's start with the first one and the last one. Why? Because this one will guarantee that we have the maximum of width. So let's say start is 0 and its length of height minus 1. And we need to store all areas since there are different cases and we need to choose the maximum one. So just say store all areas. And then when we're using the two pointers method, we only stop when both points meet. So that is why we should say while starts lower than end. Because at here we almost finish, and then this point, once we move here, it will become 0, and then everything's done. Okay, so let's get started. So let's find out the current area. The current area equals to the minimum of the height. So for example, if we use this part and this part, the H1 here and the H2 here, only the H1 is valid since we cannot slant the containers, and the containers can only reach that high amount of water. So the current area and the width is here, which are the difference of their index. So let's just drop everything. Let's just get started. So it's equal to minimum of height star end times end minus start, and then this is because the area equals to minimum of height times width. And then regardless of what happens, we need to store the area. So we say all area dot append current area. So just say store the area. Okay, so once we store the areas, what happens? You see here we have a blue line here, and then we have a green line here, and then here is the next line, and here is the next line, right? Of course, I am not following the questions strictly. You see, we have two options. We either move the blue line to the right or move the green line to the left. However, if we move the green line to the left, while the blue line doesn't move, the height or the minimum height is still this segment, regardless of how this green part. Because if we fix this blue line, even though the green line is very tall or very short, the minimum is still here. Even worse, if the green line has the length of this tiny bit, the height will be smaller than the minimum one. So in conclusion, moving the bar that have a higher height will not give us any benefit. In contrast, if we move the blue line to the right, we may increase the minimum height, right? So it can give us some benefits. Okay, so once we know that, we can just split the case. So if height start greater than height end, we will just move the end to the left. And similarly, if the height start is less than height end, we will just move the start. Okay. However, if you think more carefully, you will discover that what happens if the start and the end have the same height. Doesn't matter, right? Really. Okay, so we don't know. So let's talk about the inner layer. So let's assume that the height after the start is that much, and the height after the end is that much. So we just move left and then move right. You see, in this case, moving the start to the right is better than moving the end to the left, since the green bar is taller than the yellow bar, while regardless of how we move, the width is the same. So for this part, we need to compare the next start, which is here, and the next end, which is here. Okay, so we can just mention the height of next start equals to height of start plus 1, and the height of next end equals to height of end minus 1. If the height of next start is greater than height of next end, we will move the left. Otherwise, we will move the start. Okay, you may still see that. Let's draw the diagram again. You may ask, what happens if the next start and the next end are the same. That is, if we draw the green line here, and then if we draw the pink line here, and then if both of them are the same length, what we should do? Let's guess. Indeed, it doesn't really matter, because regardless of moving the right one to the left and the move left one to the right, the minimums of the green and the pink are still the same. And for the next stuff, we could use the same way to do so. That is, if the red one here and the yellow one here are not the same, we could still use the same algorithms to determine whether we should move the green one or the pink one. Okay, so here we can safely add the equal sign here. Okay, so once we finalize the loop, the start and the end will be the same. That is, both lines will be at the same locations. So the area is 0. So the only thing that we need to do is to get the maximum value from the all area, which is here. Okay, so just return the, so we can safely return the answer. Okay, so it's not here. So we can just say return maximum of all area. Okay, so let's put this as a test case and see what happens. Okay, sorry, so here we forget an x here, so just rerun it. All good. So let's submit it. Okay, all good. Okay, so this is the solutions to this problem. I hope you enjoy it. If so, please like this video and subscribe to the channel. Thank you and see you next time.